Okay, so we're on the home stretch. Last example, a word problem. And this word problem just happens to be an ambiguous case problem. And you'll find out right away from the drawing that this is ambiguous. So this is going to take a lot of space on your page. So you're going to want to write small and save yourself a lot of room because we want to do the full solution and then the summary chart at the end. One fire ranger station A reports smoke 30 kilometers away in the direction east, 30 degrees, should say north, sorry, at B. A second station at C due east of the fire station. First station reports that the smoke is 20 kilometers away to the nearest tenth of a kilometer. Determine the distance between the two stations. Well, the first stage in this is to do the sketch to figure out whether or not this is an ambiguous case or not. Right? So when we sketch it out, I'm going to draw the triangle here at A. And we know that this is 30 degrees east of so I'll sketch it out this way. So we'll call this A and B and C, and I'm going to narrow my pen a little bit. This is 30 degrees in here. We know that this is 30 kilometers. Here's the second station at C, and this is 20 kilometers. All right, so we have this side being less than that side, so there's potential for it to be ambiguous. If we drew an isosceles triangle here, it could connect with the base here. So from this point here, we could say that 20 divided by 30, which is 2/3, is less than 1. So there could be two triangles possible. Okay, so let's start with some calculations down here. We'll go with this one first. So we'll go 20 sine 30 degrees. Is going to be equal to 30 sine C. So we end up with our angle C being 48.6 degrees. So our angle B is 180 minus 30 minus 48.6 degrees. So our angle B is going to end up being 101.4. Okay, so we've got the three angles of the triangle figured out. The last thing we have to figure out is what line segment B is going to be. So let's go B over sine 101.4 is going to be equal to, let's say, 20 sine 30 degrees. Cross multiply and solve for B. B is going to be equal to 20 sine 101.4 degrees, all divided by sine 30. And so I'll bring my calculations up here. So B is going to be equal to 39.2 kilometers. Well, what does that mean? Okay, well, let's make a little sentence here. If stations are on opposite ends, oops, sorry about that. Fire. They are 39.2 kilometers apart. But that's just one triangle. So is there a second solution? Well, we'll figure that out now. Okay, so we know that as we shift over here, this makes an isosceles triangle. So if this is 48.6, if this angle is 48.6, then that angle is 48.6. So to find the inside angle of the small triangle, we're just going to do angle C is going to be equal to 180 minus 40, where's that number, 48.6. So my angle C is going to end up being 18.6 degrees. No, 131.4, sorry, is equal to 131.4 degrees. So my angle B is easy, because all I have to do is take 180 minus 30 minus 131.4 degrees. So angle B, although it's small, still comes out to be a positive number. That's 18.6 degrees. Okay, so I've got the three angles solved. The last thing I have to solve is this little line segment B here. So I'm just going to use Sine Law to figure out that ratio. I'm running out of room. B over sine of 18.6 is going to be equal to 20 over the sine of 30. Okay, so we'll cross multiply and solve for B. 20 sine 18.6 degrees divided by the sine of 30 degrees. So my line segment B is going to be about 12.8. So if stations are on the same side, they are 12.8 kilometers apart. Now, I'm just out of room here, so you would need to find some space. A good idea is always to have that summary chart just to make sure you've covered all your ground here. So I'm going to clear space here and do that ambiguous case chart just to make sure I have everything in place. Okay, so here we have angle A, angle B, angle C, line segment A, line segment B and C, for triangle 1, for triangle 2. So angle A is easy, right, because it doesn't change, so that's going to be 30 degrees. Let's fill in the stuff that doesn't change. Line segment A is always going to be 20. Line segment C is always going to be 30. And then we just use our calculations to fill in the rest of the information. Okay, that one works all right. And triangle 2, this angle works out here, and okay, that makes sense. And then for line segments B, we have this is 29.2, and this is 12.8. So the ambiguous case, because it's so much work, is worth a lot of marks, but you want to do this little summary chart just to make sure you're not missing anything. Okay, so you're going to go on to the next one with the two helium-filled balloons. The full solution for this is on page 476.